And we're live. What is this, Lady Ada?
Hey, everybody, and welcome to the most fun 30 minutes on the internet. It's show and tell time here at the Adafruit Factory. This is where we do all the engineering and design and manufacture and all that good stuff, the electronics that you know and love. But right now, it's your time to shine, not just this desk's time to shine, although the desk is very shiny. You're going to show us what you're working on. Is it 3D printing? Is it cosplay? Is it electronics? Is it Arduino, Raspberry Pi? We want to see everything you're doing. Just come on by. We're here from 7:30 to 7:55. We're going to call on people.
7:55 is a hard stop.
It's a hard stop.
Shout out to the guy who came up with that show, the Gong Show.
Gong.
At the end, I don't want to do that.
We don't want to have a gong, 3D printed gong.
So 7:55, whatever you're doing, drop because we got to set up for the next show.
We'll be here
See all this
next
stuff
week.
Going on, Chuck Barris. Thank you.
We're here every single week.
Okay.
Let's start off with some Adafruit crew, and then we'll call on other people.
No, Pedro.
Hey guys, it's back to basics this week. We figured we'd make a standalone project guide video on how we make little slide switch adapters. So camera over here. Yeah, so this is a circuit playground board, and a lot of the times you plug in a battery, right? And plug it in, and it's super glowy and awesome. But if you want to turn off your circuit, you kind of have to do one of two things. You can kind of program this switch here to kind of act as a turn off switch, but it's not really wired to the voltage regulator. So what you could do is fashion yourself one of these, which is basically a JST extension cable with a slide switch on the end here. So it's wired in the voltage line. And so that way you can plug it into circuit playground board or one of the boards that has a female JST connector, and then plug the battery into the other female JST connector, and I can turn on my circuit with the slide switch. So we actually use this a lot in a lot of our projects. So I figured I'd make like a standalone guide on just that. So if anybody's looking for a nice way to kind of have your project embedded and have the ability to take your battery out, you can do that. We do have this kind of thing in the shop already.
Yeah.
It's a little bit big. It's like bigger than the board. No, it's this big, but it's still kind of big. It's really nice for like wearable projects. So it's got a nice kind of latching type of button. So if you're looking for something like that, it has the same thing this way, the male JST connector and the female JST connector. So there's just a simple way to kind of get that on and off function.
Okay, timely on Ask an Engineer. We're going to talk about our Internet of Things Bill of Rights. We just added a new thing. All Internet of Things devices should have an off switch that's clearly marked. And if not, you should modify your stuff because switches
Stop snitches.
stop snitches.
Very well. That is a good slogan.
Alexa, play Wichita Lineman by Glenn Campbell. Yeah, okay.
Okay, thanks, guys.
All right. We have a full house tonight, so Noah and Pedro, if you could drop out. A couple folks want to get in. We'll do that with Scott, too. All right, Scott, you're up. Next up.
Welcome, Scott.
Hello. As you may or may not know, I'm in London right now, and I should actually be quiet because it's like 11:30 at night. But I've been really busy, and I wanted to show some pictures of what I've been doing.
Slideshow time.
All right. Hi, Becca.
Slideshow. Can you see it?
Not yet.
Shortly.
Not yet. There we see
There you
it.
go. All right.
Ooh.
Can you see what it is?
Oh, yeah. You went to the Countess of Lovelace.
Exactly. So I went where
Lamore's former avatar.
Ada Byron, aka Ada Lovelace, lived in London. Here's another picture with a nice.
Put this up on the blog later when you get time.
Yeah, sure.
It's a nice house.
All right, that's where Ada
She's a countess.
lived.
Yep. Yeah. So they do this all over London. They put these blue plaques where important people lived. This is actually on the same square as where Eisenhower commanded the Allies, I think, at least for a little while.
Popular blog.
It was another blue plaque there. And then today I got hosted by R Lab, which is a Reading hackerspace. It's a town west of London. And so I took the train out there. Jeremy was kind enough to invite me when I was like saying, hey, I'm going to be in Europe. So this is what it looked like from the outside. And then we took a tour of the bus depot. So I have bus pictures where they were talking about all the different things that they're trying to do with their buses to make them more innovative. This is the front of a bus where they actually make the logo in the front light up, Reading buses. And then this is a double-decker bus on jacks, which I thought was kind of amazing.
Wow.
Whoa.
That's a bus.
That's so
Yeah,
tall.
they're huge. Yeah, so you can get underneath it. And then this is a woman, Zara, who was working, and she has orange hair. So I thought that was really cool. She's a mechanic working on the buses.
Yeah.
It's a requirement.
And then this is in the top of one of the double-decker buses. This is some of the other Makerspace guys, plus John, who's the guy that hosted us, and talking about different layouts that make their buses more innovative. Like this bus was for their university route, and they have these tables so that like larger groups can sit together. And behind the guy on the left, there's a bookshelf with books and stuff on it. Which
No
is
way.
pretty neat. And then they have this like open lounge area in the back. They actually have a Bluetooth speaker you can connect up to as well. So they're doing a lot of experimentation with materials and stuff.
Very cool.
And then this is back at the hackerspace. I didn't get a ton of pictures, but this is more of their like sanders and stuff that they had down below. And then this was a emulator that somebody was making. It's based on a PIC, but it runs a bunch of older assembly stuff like 6502 and things. Mostly behind my time, but they did a really cool job of that. And then on my way home, I saw Mind the Gap on the subway, so I thought I would show that.
Very cool. Well, please post these up on the blog so that folks can see them. And thank you for using the internet for an excellent purpose, which is to show vacation slides.
Yeah, I hope nobody got too bored by watching those. But
No,
yeah, I got two more weeks of vacation, and then it's hitting CircuitPython really hard after that.
Okay, they'll put a plaque there one day. This is where Scott took photos and was working on some CircuitPython stuff.
We'll see. We'll see.
All right.
Thanks.
All right. If you could pop out, we have a full house, Scott. So
Yeah, we'll do.
Thank you.
All right. Welcome back, Adam.
Hey, Adam.
Can you guys hear me?
Yes.
Yeah, you sound great.
Yeah, cool. So I got more progress on the microscope. The big thing this week was I actually powered it up for the first time, which was incredibly scary. I don't want to blow any capacitors, and these things are from 1980, so a little bit nervous with releasing the magic smoke there. The other thing was, though, is that in powering up, and I'm going to share screens real quick because I can't get a camera around back, is that I could get my vacuum gauges working. So I could actually see how good my vacuum pumps are working. And this, can you guys see my screen?
Mm-hmm.
Yep.
Yeah, so this thing should be all the way in the green area with the main vacuum pump, and it's not, which is a problem. So I started looking into my vacuum pump and discovered that the oil looked like that. It should be perfectly clear, so I had to take this whole pump apart now and clean it out manually. This pump's actually got quite a bit of history. I found out this week is this thing was used on the Space Shuttle Columbia to test the reaction control thrusters on the ground. So this is what they used to vacuum out the environment around the thrusters and test them out before they launched it. So this is the actual pump from Cape Canaveral, which I was kind of really excited about.
Wow. Thank you for showing that. I mean, this pump is probably one of the most important things for someone at some point in time, and now it's getting shared on the internet.
You should put a blue plaque on it.
Blue plaque.
Blue plaque.
As you know,
Yes, this pump is actually, so it did Space Shuttle Columbia, and then its next life was working on a nuclear reactor for high school students to teach them about basic nuclear physics. And then that group upgraded, so I got the pump from them. So it's had quite a history so far.
Outstanding.
The issue with the microscope is, of course, that it's a Japanese microscope, so I got to get 100 volts out of this thing. So it came with this transformer, and this transformer is wound such that every coil is acting like an auto transformer as well as a transformer. So in order to get 120 down to 100, which my line voltage here is, it was actually giving me plus 38 volts to ground on both neutral and hot, which was really bad for the microscope. So that thing's gonna have to be replaced with the Variac at some point, but the windings on it are complex. I'm not gonna touch it. And the last big thing was the high voltage system. So this is the high voltage system. This microscope requires 25,000 volts to accelerate the electrons to the point where you can actually make an image with it. So all the, it uses what's called a Kharkov-Walton step-up ladder to get it up to that kind of level, but the whole thing's submerged in this oil. Now, this oil kind of scared me at first because I thought, oh, PCBs are bad. I enjoy being healthy, so I didn't want to touch this thing until I knew for certain. So I got out an old piece of equipment I got at Surplus, which is called a Fourier transform infrared spectrometer. I picked this thing up for $35 from a Surplus store in Seattle and refurbished it. I was actually able to use a 3D printed jig I built to suspend the oil in the machine's beamline to make sure that I wasn't dealing with any PCBs. So once I had that confirmed, I opened the thing up and started servicing it. So quite a few different projects coming together to make this one thing work, but
Pretty intense.
pretty fun.
I also have my $35 spectrometer. It's in my purse. I'm gonna grab it.
Outstanding, Adam. We'll keep coming
Sweet.
back because this is an excellent project to share. Maybe we'll do a supercut.
I'm learning a lot.
when you get it going. And,
Yeah.
of course.
These systems are complex, and I'm learning everything from high voltage, high vacuum, nanocurrents. I got to get into the oscilloscope in the coming week to actually start testing this thing out. So
Yeah,
Okay.
it's as
see
if
how it
it
goes.
was used by rocket scientists and nuclear scientists.
All right. Well, stay safe.
All right. You
Yeah,
get a
that's the
show
idea.
and tell sticker. I don't have a nuclear one yet, but I'll work on
We
it.
should get one.
I know.
Okay.
Put it in the request box. Okay, next up. Alex, how's it going, Alex?
Hey, Alex.
This Alex? I never know.
Yeah,
Hi, what's up?
Hey.
Hey. I was gonna share the new Hackster apps.
That's right. I knew this was coming.
technically my project. It's all our entire team. But yeah.
Shout out to Artie for setting this up too.
Oh yeah! Shout out to Artie. I know he's watching.
All right.
So
Do this quick
yeah,
now.
it's basically an in-browser suite of tools for end-to-end hardware creation. Yeah, so we're starting out with two, which are Circuito.io and Upverter, and basically we've taken these services and embedded them inside of Hackster with single sign-on, so that it's super easy.
Oh, that's
So
cool.
Circuito is basically it. It's a drag and drop interface for putting together bits of hardware, and then it generates Arduino code and schematics and how to wire it up and a bill of materials so that you can create basically a basic project, then customize it. And then Upverter is basically you take whatever project you have and turn it into a PCB. So it's got like the full suite of tools plus really cool humans to help you out with that process. So you can like ask someone to check your layout before you send your board off to be made so that you don't wait for weeks and then, it doesn't work.
Oh, that's cool. This is like a super duper upgrade to like fritzing, because some people have tried to cobble together things in fritzing, but very hard, very challenging.
And how many hundreds of dollars do we have to pay for this service?
$0.
It's free. You guys are crazy. What's going on over there?
You want to show it off? Because we're going to get to everyone
We've
tonight.
got sugar daddies like Intel paying for it. I shouldn't have said that.
Don't worry.
We'll edit it in post.
This is not live or anything.
Yeah, so anyway, you can check it out at hackster.io/apps and see what else we've got coming up, like Blink and Microsoft code for Microbit and resin.io for working with Raspberry Pi. And then you can also see an intro video at bit.ly/hacksterapps. Thank you guys so much for having us on. I'm so
very cool.
Yay.
And this is neat because Hackster has really good tutorials, so then you'd be able to kind of do everything there and then send off your files to Oshpark or something. That's cool.
Totally.
Sounds like good stuff coming over at the
All right.
Hackster Labs. Thanks,
Yeah,
Alex.
we just had Altium interviewed during the week, so this is all coming in. It's never been a better time to be a maker.
Awesome. Thanks, guys.
All right, you get a sticker. Email support@adafruit.com, and you can wear the ISM on Show and Tell sticker.
You are on Show and Tell.
Yeah. All right. Next up, Sally. Welcome back, Sally. Unmute your mic and show us your project.
Hey, how are y'all?
Hey.
Yeah, I finished this skirt. I'm gonna have to stand on this chair again. See if you can see it.
Oh, cool.
Oh, neat.
Resist skirt.
Yep, resist. And the red and green go from one direction and the blue goes in the other, so they cross.
Oh, cool.
Oh, neat.
Yeah, it's going around.
Oh, cool.
Yeah, it goes clockwise, I guess. And I'm going to add another color because I end up with the front of the skirt unlit altogether at long periods of time. But that's basically it. And it went to the Maker Faire on Sunday, the Nova Maker Faire, and was very popular.
That's very cool. And you can always put some type of fabric or material on top of it if you ever want to change it up and have it diffused or something like that too. It's so
Well, partly it just needs that for protection.
Yeah.
Because those angles are really bizarre to solder.
Yeah.
And there are lots of really weird, tiny little pieces of wire that cross and so on. So I'm just going to put some cloth on top to keep them from snagging.
Yeah. Outstanding. Well, thank you so much, Sally. And of course,
But it lasted. It went through the whole fair without breaking.
The ultimate test.
Yeah.
Didn't make it through the Maker Faire.
Pretty much. But,
all right. Maker Faire tested. All right. Well, in addition to probably some Maker Faire ribbon you may have got, email support@adafruit.com and you get a As Seen on the Show and Tell sticker, but you could probably badgeify that, put that on there too.
Okay. Great. Thank you.
Right.
All right. Thanks so
All
much.
right, we're getting to everybody.
We're going to get to everybody. Everyone moves quick. All right. Next up, John.
Hey, John.
Hey, how you doing?
Good.
Hey.
Here as well.
Hello.
his project is.
Hi, it's both our project. Let me show you what we're working on. So we've been making instruments on which we hook up motors. So this is, like, you can't see all of it, but stay with me. This is a string instrument, and the way we activate the strings is by these discs, which are mounted on motors. So they're kind of automated. I don't know if you can hear it.
Yeah, totally.
Yeah,
that's great.
that's cool.
All right. So I'm using this very cheap motor controllers I found on eBay to use this. And I'm going to show you a new version of this, which is, it doesn't have the motors yet. So it's this thing, right? And it's completely acoustic. Let me show you, make a very fast demonstration. So again, this is a little motor, a little more, and I have a disc mounted on it. So all right.
There's a great band called Godspeed that that's how they play music.
Very ambient. I like it.
Very cool.
Thank you very much. So now I'm gonna hand you over to John, where he's gonna talk to you about the technical problems that we have.
Okay, great. Just make it spiffy so we can get everyone in, and you definitely get show and tell stickers no matter what. So take it away.
Cool. Well, I mean, I think our one problem, especially with this acoustic one, is the motor itself. It's very noisy, and if anyone, you or anyone, has any recommendations for the type of motor, we've been experimenting with them, but we haven't found one that's quiet enough, that has a high enough torque to where it can be pressed on the strings and make the noise without interfering with just the acoustics of the instrument itself. So that's our main problem, I would say.
Right.
And I think, you know, just to go quickly with it, the other thing that we want to do, we're working on kind of making a sequencer of it. So as there's some knobs, you didn't get into it too much, but where you can adjust the speed of the motors, and that changes the sound, and we want to record that. So we've got an Arduino with the motor shield and also a data logger shield. So the ultimate plan is to record the controls of the motor and be able to play that back or loop it or do that kind of things with it. But the motor is kind of where we're stuck, really.
Noisy robots.
Yeah. So I don't know if there's any resources for that, like where to, like, ideally we can, ask someone who really knows about motors. But yeah.
The power of the crowd.
That's where we're at.
Post up in the comments if you can help.
Yeah, sure.
Absolutely. All right. Well, thank you so much. Email support@adafruit.com, and we'll send you a sticker. Also, mute your mic. We get a little echo, but I got to keep moving here. Next up, Bill. Bill, go for it.
Hey, Bill. Welcome back.
Oh, Bill, can you unmute your mic? No. How about we go to someone else, Bill, and we'll come back to you.
We'll come right back.
All right. Next up, Scott. Unmute your mic and show us your project.
Hey, Scott.
Hey, guys.
Hey, I can hear you
make
just
it-
fine.
Just make it speedy.
Okay, so I'm back with the Perbox version 2. I've actually got two different variants of it here. There it goes. So right along up in here, there's a red LED. Whenever I press it, it actually lights up and flashes as I'm holding onto the head. And it's actually linked into the haptic controller, so it's flashing with the motor. And I actually have a second version for somebody else, the finger button for them, because I don't want to sit there and mess with the head like they do, or like I did. So same thing, different version. Pretty much it for this week.
Cool.
All right, we'll keep coming back, Scott. You can keep collecting the show and tell stickers, and when you're all ready, take a photo and more, and we'll post it up on the blog.
Love your hoodie.
Awesome.
Yeah.
Thank you.
All right, we're gonna try to go back to Bill. Bill,
I tried a different mic. Any better?
Go for it. Speed round. Great.
Yeah.
Go quicker. So it's kind of funny. Susan was at, or Sally was at Maker Faire Nova. We actually, our current project is being driven by some kids that were just at Maker Faire Nova. I'm gonna try and share my screen here for a second and show you. I remember how to do that. Yep, hold on. So this group right here, can you guys see that?
Yep.
Yeah.
All right, so this is the kids from Harmony Middle School, have an AT Makers Club, and they were at Maker Faire Nova in Northern Virginia and showing off all their good stuff. And they actually are pushing me on this week's project. We actually have 3D printed switches, and they're the ones who are asking us for that. And they want to do that so they don't have to use the CD cases they've been making them out of. On that, let me turn my camera back on and I'll show you. I think. Yep, we're back. Yep. So this is actually the switches. I made a video showing this. It's 3D printed. It does have about 6 cents worth of Adafruit equipment in it. There's a tiny little tactile button in there. Really easy to make. I mean, even the video explaining how to make it was about 20 minutes. But this is that they can print out, or those kids don't have a printer, so they're going to send it to 3D Hubs. And then the other thing that was requested this week that I'm happy we were able to make progress on is this. It's just finished printing. This is made out of PETG that goes on a mobile wheelchair, clamp on a dog walking stick, a button that will attach to their bikes. It lets you attach that to your power chair, take your dog for a walk. These are all requests for the Facebook group, and we're turning them around quickly. It's great. About 2 days, they're getting these ready to go.
All right. Well, thank you so much, Bill. As always, you can get a show and tell sticker to email support@adafruit.com. We're going to get Orlando and then Kirby and then C. Scott, if y'all can keep it to about a minute each.
2-3 minutes. Hey. All right.
All right, Orlando.
Brain Orlando.
All right, so I made a DIY super simple EXG circuit for all the different, electrocardiograms and such. So right now I have the electrodes on my wrist. I'm measuring my electrocardiogram. Because my muscles are moving, it's going to take a while for it to get steady.
Mm-hmm.
Crappy. You can see there a little bit.
Yeah.
Yeah.
Cool. So now if I move it to my face and do EOG, or look at the muscles in my cheeks, take it a while to get steady again.
Okay.
I'm like gnarling my teeth a little bit. You can see it responding to that as well.
Neat.
So it's kind of a simple way to get all the different biopotential measurements.
That's so cool.
All right, cool.
Outstanding. All right, thank you so much. And of course, you get to ask on the show and tell sticker if you want another biohacking badge.
I love the use of the portable oscilloscope. It's a good idea for this kind of stuff. It's good idea.
All right, stuff with Kirby, then we'll go to Scott, then we got to go. Stuff with Kirby.
Hey, Kirby.
Hi. All right. So last week for Pi Day, there was a contest on Hackster.io to make a Pi project. And I made a little memory game to see how many digits you can count to Pi using Pi 0, the display, and the keypad. So after I got it done, I realized that I could have used the Nokia display that I had. So I'm going to redo it to work with that, since with the 16:2 I can only count up to 32. And I made the case on my Shapeoko, and here's just a one where I put together and realized I didn't have room for the Pi, so I had to redo it.
Cool.
And then here's my speed timer. That project went live this week.
Yep.
So that one's kind of cool though. Hot wheel comes in from the side, hits the two sensors, and tells you the speed.
Yeah, you take it.
So AdaBox 3 comes with all the parts except the sensors. So if you have those, you can make one or time something else. So it's a pretty cool project.
Whoa.
Very cool. And thank you for doing the tutorial.
Yeah, that's great.
All right.
Now I just got to find which car is faster.
All right. Outstanding. Well, you
Thank
get a
you,
show and
Kirby.
tell sticker and see Scott. Play us out. Oh, see Scott. We see your screen, but we don't hear you.
I can tell it's a 3D printer with some kind of power problem. Looks like a heating bed, maybe.
Yeah,
exploded
looks like
there.
he. So we're gonna have to do maker charades, and we'll just bounce. So
Yeah.
I think, see Scott, if you type in the chat.
Hotbed. It sounds like it would be the heating bed of a 3D printer.
This is a
The
Melzi
Wanha.
board from a MA Wanaloo i3.
Some 3D
It has
printer,
problems.
low cost.
I have a
3D
feeling you're going to fix it with a better problem.
There's been people who've shown up on the show and tell them, they said like these 3D printers, the mechanics are good, but the electronics, they're way under spec. You know, it should be taking 10 amps and it has these
Yeah.
2 amp
Scott
connectors.
says note the burnt connectors.
This is why.
This is why.
Ah, jeez. Dude,
Oh no.
come on, put a little bit more clearance there. Maybe don't use thermals.
Yeah.
Yeah, that's way too close. It's 1 ounce copper. And thermals. Yeah.
100 mil of width. Yeah, that'll do it. Not good.
I actually have some issues. Just sometimes the fab houses, they don't check, and there's little piece of copper can bridge the.
Yeah.
I like when I have big power connections. I like to give it at least 30 mil of distance.
All right. Well.
All right. We'll redesign it.
All right, see Scott, we're gonna bounce. So
I like how they got little happy faces.
one of them isn't happy, and one
The
of them
power
a
one
little
is kind of
upset.
grumpy. The hotbed's a little sad. The hot end's really happy. And no more thermals. Yeah.
Outstanding. All right. Well, thank you, everyone. Thank you, Kirby. Thank you,
Happy
Scott.
terminal
Thank you, Sally. Thank you,
blocks.
Orlando. Thank you, John. Thank you, Scott. Thank you, Bill. Thank you, Adam. We're every week, 7:30 p.m. Eastern Standard
We got to
Time.
like 15 people.
We got through a lot. We'll see everyone on Ask an Engineer in just a few minutes.
Thank you,
you so
everybody.
much, and thank you for making this the best half hour of our week, every single week. Show and tell.
Okay.
Everybody.
Bye.